Welcome, PreCalc, to lesson 4.3, trigonometric functions on the unit circle. The learning targets for this lesson are that you can find the trigonometric values for any angle and that you can find values of trigonometric functions using the unit circle. We've already worked a little bit with the unit circle. We're going to work a lot more with it in day 2 of this lesson. For the purposes of this video, we are focused on, at least beginning, looking at finding trigonometric values of any angle. Part of this we will need our calculator for. Finding trigonometric functions of any angle. When we are looking at points in space in the coordinate plane, two-dimensional space, we can create a circle in that plane. We have our x-axis, we have our y-axis. And we could create any angle going into any quadrant. So as long as I have an initial ray and a terminal ray, we create any angle going to any quadrant. This point right here has an x, y coordinate value. Going to the height, it is y units high, in this case down so many units. And going up to the x-axis, it is x units to the left. It creates this right triangle with the positive x-axis. We always want to look at, or not the positive, with the negative x-axis. We always wanted to draw these with creating an angle with the x-axis. So if it's in unit 1, we have our terminal ray, we drop a line down. If it's in quadrant 2, there's our terminal ray, we drop a line down to create our right triangle. If it's in quadrant 3, we have our terminal ray, we pull a line up to the x-axis, and if it's in quadrant 4, again we pull a line up to the x-axis, creating these right triangles. If this is the case, we're concerned with finding sine, cosine, tangent, and the inverse trigonometric functions of this angle. And we'll be talking about its reference angle in a little bit, but the idea is, so we have an angle, we're just going to say that angle is at this vertex. So we can focus on this being the angle, even though the whole thing is the angle. The sine, because this would be the height, y, and this would be the distance, x. And the hypotenuse of the triangle is the radius of a circle that's spinning around. So the hypotenuse is our terminal ray, or the radius of a circle that would be spinning around in the coordinate plane. All right, so what we have is that our radius is equal to the square root of x squared plus y squared. That should look familiar. The equation of a circle at 0, 0 is x squared plus y squared equals r squared. We could quickly find our radius if we know the x and y value. The value of sine of the angle, well, if this is the vertex of that angle, is opposite over hypotenuse, so it's y over r. Cosine of that angle is adjacent over hypotenuse, so x over r. And tangent of that angle is opposite over hypotenuse, y over x. By the way, y over x, look at that. If I'm looking at this line, I go up y units and over x units. That is rise over run. It is the slope of the terminal ray. All right, now we also have to do the other 3 functions. Remembering that cosecant is the reciprocal of sine, we have r over y. Secant is the reciprocal of cosine. We have r over x, and tangent, cotangent is the reciprocal of tangent. Cotangent would be x over y, or the reciprocal of the slope of the terminal ray. So now we have our trig functions defined on the coordinate plane. If I give you any point to form a terminal ray with the point 0, 0, you should be able to, knowing that x and y value, find the radius and give me all 6 trigonometric ratios. The trick with this is, though, we have to be careful because in this case we've gone left and down. So x is negative and y is negative. So that makes this, and this function are going to be negative. But y divided by x, negative divided by negative, will be positive, and so would x divided by y. So we have to be careful about our signs. All right. The given point lies on the terminal ray of an angle in standard position. If the values of the find the six values of the trigonometric functions of theta, state the quadrant each point lies in. So we're going to start, notice folks, these are all 5 and 2, so our radius is going to work out the same for all of these, because even if they're negative, when I square them, they become positive. 5 squared is 25, 2 squared is 4. We're going to have a radius of the square root of 29, which cannot be broken down. But that's going to be for all 4 of these. It's not often how it'll work, but to make my example to you so that you can see the difference in the signs, that's what we're looking at right now. All right, so I draw it in standard position first. I have my x and y coordinate, or x and y axis. There's my initial ray. This point is right 1, 2, 3, 4, 5, and up 2. It's right here. So it's a rise of 2, a run of 5, that's going to be our slope, and a hypotenuse or radius of the square root of 29. With respect to the origin, the angle that's sitting at the origin, the sine of this angle is opposite over hypotenuse, or y over radius. Before I rationalize this, I'm going to write cosecant because it's going to be flipped, and I don't want to have to re-rationalize it. So there's cosecant, square root of 29 over 2, since square root of 29 could not be broken down. The reciprocal of this for sine, or not reciprocal, rationalizing this would give me 2 square roots of 29 over 29, which can't be reduced. For cosine of theta, for this one, I have adjacent over hypotenuse, 5 over the square root of 29. So I'm immediately, before I rationalize, going to do the reciprocal value to get secant. There's secant, square root of 29 over 5. Then I'm going to rationalize this. This is 5 square roots of 29 over 29. Lastly, we have tangent. We have y over x, or opposite over hypotenuse, 2/5. Cotangent of theta is 5/2. Notice we are in quadrant 1, and in quadrant 1, all trigonometric ratios are positive. That's because our x is positive, our y is positive, and the radius of a circle is always positive. So all 4 in quadrant 1 are all 6 are positive. Let's take a look at what happens when we move into another quadrant. This time we're going to go back 1, 2, 3, 4, 5, and up 2. So we've gone up 2, but we've gone left 5. It's very important to put that negative on there when you go left. Our radius still calculated the same way because negative 5 squared is still positive 25. So square roots of 29. The value of sine is opposite over hypotenuse. So again, rationalized, 2 square roots of 29 over 29. Notice it's positive over positive. Cosecant, again, the reciprocal of 2 over square roots of 29 is square root of 29 over 2. Cosine gets a little more interesting. Cosine theta now is the adjacent over the hypotenuse, or x over r, negative 5 over square roots of 29, which we know when we rationalize is negative 5 square roots of 29 over 29. And secant, actually, is negative square roots of 29 over 5. Because we've gone left, that x value changed. So everything that depends on x, notice sine and cosecant don't, but cosine, secant, tangent, and cotangent will all be negative possibly. And they are for this. So this is going to be negative 2/5, and cotangent will be, of theta, will be negative 5/2. We are in quadrant 2. It's 1, 2, 3, 4. Make a C as you go around for the order of the quadrants. For letter C, I'm going to draw this out over here. We go left 5 and down 2. Again, we're going to have a hypotenuse of the square root of 29, still positive, but we've gone left 5 and down 2. So the sides of the triangle are now negative. When we have application problems, we don't do that, but when we're working within the coordinate plane, left and down have a sign that determines their direction, and it's important for us to include that. So we have again sine. This time sine will be negative because it's negative 2 over square root of 29, which is going to be, when rationalized, negative 2 square root of 29 over 29. Cosecant then will be, instead of square root of 29 over 2, it'll be negative square root of 29 over 2 because the net 2 was negative and 29 was positive. Cosine of theta will be x over r, or adjacent over hypotenuse, negative 5 over square root of 29. We already know what that is. Negative 5 square root of 29 over 29. And secant, we already know what that is. Negative square root of 29 over 5. Now, I've had people before tell me, oh, they're all going to be negative. Well, not so. Because when I go to do tangent of theta, which is y over x, or opposite over adjacent, remember theta is at the origin here, that's negative over negative, which negative 2/5, or negative 2 over negative 5 becomes positive 2/5. Cotangent similarly will be positive 5/2. So in this quadrant, quadrant 3, tangent was the only one that was positive. In quadrant 1, all were positive. In quadrant 2, only sine was positive. Let's see what's going to happen in quadrant 4. Some of you probably already know. In quadrant 4, we've gone right 5 units and down 2 units. Radius is still positive. This means that our opposite over hypotenuse is going to be just like it was in this quadrant, negative 2 over square root of 29, which means that our sine value and our cosecant value are going to be negative. Negative 2 square root of 29 over 29, and for cosecant, negative square root of 29 over 2. Cosine, however, this time the x is positive, the hypotenuse or radius is positive. So just like in quadrant 1 where they're both positive, my cosine of theta, when I rationalize it, is 5 square root of 29 over 29. My secant of theta will be square root of 29 over 5. Tangent is a little different. Tangent, we have y over x, or opposite over adjacent. This is negative 2/5. Cotangent, therefore, is negative 5/2. Because 5 over negative 2, the whole fraction is still negative. So in quadrant 4, which is what we're in now, sine and tangent were negative. Cosine was the only one that was positive. So in quadrant 4, cosine and secant were positive. In quadrant 3, tangent and cotangent were positive. In quadrant 2, sine and cosecant were positive. And in quadrant 1, all of them were positive. That leads us to the following expression, which some of you may already know, or two expressions actually. When we're working in the quadrants, in quadrant 1, all signs are positive. In quadrant 2, sine and its reciprocal are positive. In quadrant 3, tangent and its reciprocal are positive. And in quadrant 4, cosine and its reciprocal are positive. Two phrases or mnemonic devices that can help us remember the order of signs. So here all are positive, here sine is positive, here tangent's positive, here cosine's positive, and their reciprocal values as well. So the two phrases are all students take calc, or a smart trig class. You can pick either one, which you want to use. I often use a smart trig class because not all students take calc, but many do. So you can pick whichever device you want. But this is to help you remember the primary functions. In quadrant 1, all three, sine, cosine, tangent, and their reciprocals are positive. Quadrant 2, sine, and so this is all 6. In quadrant 2, sine and its reciprocal, which is cosecant. In quadrant 3, tangent and its reciprocal. And in quadrant 4, cosine and its reciprocal are the only ones that are positive. All other signs are negative. So what's nice about this little mnemonic device and this trick is that as you do ordered pairs like the ones above and like we're going to be doing, if you know the xy coordinate, you can see it and hopefully get the sign right. But you have this as a double check. So here's my answer when I'm in quadrant 3. I know that only tangent is supposed to be positive, so when I'm done, I double check, is tangent the only one I left positive? The other ones should be negative. Hey, I did it right, except I don't see my negative sign on that one, so let's make sure we put that there. So that can be helpful. It's also helpful for problems like the one below. They're telling us the value of tangent. Tangent is y over x, rise over run. It is positive. Because it's positive, we are either in quadrant 1, where all signs are positive, or quadrant 3, where only tangent's positive. The follow-up information to that is that sine is less than 0, meaning that sine is negative. So we have to be in quadrant 3, because that's the only one where tangent's the only thing that's positive. So I draw a triangle in quadrant 3. My angle at 0, 0, the right angle, the terminal ray going down into quadrant 3, and then a line coming up to the x-axis. And I remember that for tangent, it is rise over run. So they had 5 over 12, or you could treat it again, opposite over adjacent. But to get to this point, they had to go left 12 and down 5. Now, if you forget those signs here, that's okay, as long as you remember that in quadrant 3, tangent and its reciprocal cotangent, which will be 12/5, are the only ones that are positive. Everything else should be negative. I now pull out my handy-dandy calculator and make sure to calculate that radius. -5 squared is 25, -12 squared is 144. That's the square root of 169, which is 13. So since our radius is always positive, this is going to give me a sine value of -5 over 13. Can't be reduced. A cosecant value of -13/5. A secant value, cosine is what I do first. Cosine value of -12/13. And a secant value of -13/12. And then I just double check. All students take calc or a smart trig class. Only tangent should be positive in quadrant 3. Tangent and its reciprocal are positive. Everything else is negative, so we're good. Let's try this for letter B. In letter B, they've given you the secant value. Secant is the reciprocal of cosine, and cosine is positive in quadrants 1 and 4. 1 and 4. Tangent is negative, however. In quadrant 1, tangent's positive, so it can't be quadrant 1, it has to be quadrant 4. So I draw a terminal ray, it can be any length, I don't really care, in quadrant 4 and come up to the x-axis. Secant, I don't like secant, so we're going to find cosine first. Cosine is the reciprocal of secant, so 1 over square root of 3, which when rationalized is square root of 3 over 3. But it did start as 1 over square root of 3. So I have to remind myself that cosine is adjacent, 1, hypotenuse, square root of 3. So this is what I have, 1 over square root of 3. Secant would then be square root of 3 over 1, which is what we have. Now, going right is positive, hypotenuse or radius is always positive. This is going down, so it should be negative, but we have to calculate it. So I have square root of 3 squared, which is 3, minus 1 squared, which is 1, which is 2, which means this is negative square roots of 2. No, this is not a special right triangle, although the numbers looked like it might be at first. So we found cosine, we already had secant, now we have to find sine. Sine will be opposite over hypotenuse, or y over x, or sorry, y over radius. Sine of theta would be negative square roots of 2 over square roots of 3. When rationalized, before I rationalize though, I'm going to find cosecant, which is negative square roots of 3 over square roots of 2. That stinks, we're going to have to rationalize them both. This is going to lead to negative square roots of 6 over 3. This one's going to lead to negative square roots of 6 over 2. tangent won't be so bad. Tangent will be opposite over adjacent. Tangent of theta is negative square roots of 2. Cotangent of theta will be 1 over negative square roots of 2, the reciprocal, so we will have to rationalize negative square roots of 2 over square roots of 2. Again, even though I think I did this right because I paid attention to going right and down, right being positive, down being negative, and the radius always positive, I will double check my signs. In quadrant 4, only cosine and its reciprocal, secant, should be positive. All other signs, sine, cosecant, tangent, and cotangent, should be negative. I'm going to ask you to try this very quickly for letters C and D. Pause the video and give it a try for letters C and D. Welcome back. For letter C, sine is 5/7 and cotangent is positive. For tangent to be positive and sine to be positive, we must be in quadrant 1. So this means that when I draw my triangle in quadrant 1, sine is opposite over hypotenuse, or y over the radius, 5, 7. 49 and 25 is 74, which I do not believe can be broken down. Nope. So just the square root of 74. So this gives us, we know sine, we now know cosecant is 7/5. We know cosine is, wait, I put the 7 in the wrong spot. That's totally my mistake. Cosecant is still 7/5. Sine is opposite over hypotenuse. I did that right, I just put the 7 in the right spot. So 49 minus 25 is 24, which can be broken down. 24 divided by 4 is 6, so this is 2 square roots of 6 for the positive x-axis going in the right direction. So this becomes 2 square roots of 6 over 7. The secant then would be the reciprocal, which would be 7 square roots of 6 over 12. The tangent will be 5 over 2 square roots of 6, which rationalized will become 5 square roots of 6 over 12. And the cotangent will just be 2 square roots of 6 over 5. For letter D, they've given us cosecant, so I will immediately find the reciprocal to find the value of sine. Sine, therefore, is 1/4. Cosine is positive and sine is positive, so again, I must be in quadrant 1. Since sine is 1/4, there's the 1, there's the 4 for the hypotenuse. 16 minus 1 is 15, which cannot be broken down, so we leave it as square roots of 15. This means that the cosine of theta, which we know is positive, is square roots of 15 over 4. The secant of theta then would be the reciprocal 4 over square roots of 15, which rationalized as 4 square roots of 15 over 15. The tangent is 1 over square roots of 15, which will be square roots of 15 over 15. And the cotangent is just the square root of 15 over 1. This concludes the first clip for day 1 of lesson 4.3. Have a great day.